Welcome back, everyone. We're going to start with the standard deviation. The standard deviation is a measure of variation. And another way of calling it, the standard deviation is the average deviation from the average. Think about that. It's the average deviation from the average. So as you hear this, I want you to think to yourself that the word average is very important to statistics in general, and it's really important to standard deviation because you basically have two averages. You have the average, and then how much does the average person differ from the average? So that's what it is. And it might seem very foreign, but I promise you we're going to work with the standard deviation over and over throughout the semester, and little by little, you're going to get a better and better sense of what it means. This is the formula for standard deviation, and of course, I'm going to walk you through the steps of how to calculate a standard deviation. But for now, just say to yourself, okay, that's the formula. Maybe you can start thinking, how would I approach it? What's the order of operations? But more important to me than all of the math that you could ever do is really understanding what it is and why we do it and what it means. So that's really where I want to start. So again, the average is an important word for the standard deviation because it's the average deviation from the average. But I find that a lot of students don't understand that, or don't know that the average is a magical number. So I'm going to make the case right now that the average is very important to understand in general, but particularly for the standard deviation. So let's imagine we have a data set with 8 observations. 6. 1, 2, 3, 4, 5, 6. So 6 scores. And we could calculate the average for these 6 scores. And our average is going to be 81.5. This is, if you need practice, add up all the scores, divide by 6. You should get 81.5. If you don't, let me know, and I would have an error. So the average is 81.5. So how much does each score in our data set deviate from that average? So the first person got an 88, so we subtract 81.5. They get a positive 6.5. They did better than average. The next person, 92 minus 81.5. They did 10.5 points higher than the average. The next person got a 67. They, when you subtract it from 81.5, they get a negative 14.5. So do you see what we're doing here? We're taking every score, subtracting it from the average, and some are positive, some are negative. That makes sense. What's so magical about it? Well, let's go even further. What happens if we add up all of our deviations? 6.5, 10.5, negative 14.5, plus 0.5, negative 6.5, plus 0.35. You get 0. If you find an average for a group of numbers, if you subtract the average from each score in the data set, and if you add up those deviations, it will always be 0. Did you know that? I find that a lot of my students don't know that, and it's an important feature of the average. So it's a magical number. I like to think of the average as the center of the seesaw. If you have a data set and you calculate the average, and you put the positive numbers on the left-hand side and the negative numbers on the right-hand side, it's the perfect center of the seesaw, and it'll be completely balanced. Sometimes it's a tiny hair off because of rounding and things like that, but for the most part, it is that center of the seesaw that balances the world. So people who do statistics, we love the average because we know how powerful it is. But you might notice that it's a little bit of a problem because we want to know what the average deviation from the average is, but when you add up all the deviations, you always get a 0. So it's almost like mathematically we're trying to figure out the average deviation from the average, but we're getting a 0, so it's actually, we're not able to do anything. It's like we're stopped in the middle of our tracks. Luckily, mathematicians are very smart, and they figured out that we can still calculate an average deviation from the average. We just have to do a little bit of mathematical magic. So the standard deviation is a measure of variation only for interval ratio variables. If it's nominal or ordinal, you cannot do the standard deviation. And it's equal to the square root of the variance. So sometimes you'll hear people talk about variance in statistics. They'll say, oh, what's the variance? Variance is how much diversity. But variance is very difficult to interpret. So what we do is we use the square root of the variance, and it's called the standard deviation. And standard deviation is still difficult to interpret, and I'm going to teach you how to interpret a standard deviation. But variance is even harder to interpret. I can't interpret a variance. I can interpret a standard deviation. So it's the most frequently used measure of variability, and sometimes we call it SD, standard deviation. Sometimes we just call it S for standard deviation. But it's the average amount of variability in a data set. This is our formula. S equals square root of the summation of x minus x bar squared over n minus 1. So if you look at that formula, which we're going to go through, we're subtracting every score from the average, and then we're squaring it. Then we're dividing by n minus 1. Normally when you do an average, you're dividing by n, right? That's the formula for average. But for standard deviation, we're going to use n minus 1. Okay. So again, I want you to understand the terminology we're using. So just think about these symbols. You might want to create flashcards again. S equals standard deviation. You can call it SD for standard deviation. Sigma is telling you to add up everything that follows, add up all the scores. In statistics, we use X or Y. We use both of those. We use Z. I mean, there's a lot of letters that we use to stand for a variable, but the ones you most commonly see are X and Y in statistics. So instead of Y bar, we have an X bar. Again, it could be a Y bar. Totally acceptable to see a formula with Y bar in it. Y minus Y bar, something like that. And N, again, is your sample size. So you're starting to see the same notations over and over. And I hope you're realizing, okay, the sigma sign, I'm going to see that. X bar, Y bar always means the average. And N is always going to mean the sample size. Okay, my goal right now is to walk you through the formula for standard deviation. So standard deviation equals this formula. And first thing that's really important is when you're looking at this formula is that there's a Y. So Y is our variable. Y bar, that's our average for this variable. And N is the total number of cases. Sigma means to add up all the scores. So let's go through it one step at a time. Your teacher I could give you an average and say, calculate the standard deviation for this data. Or I could say, here's a set of data, calculate the average and the standard deviation. So step one is finding the average. Add up all the scores, divide by n, that's your average, right? We just went over that earlier. So you should know how to calculate an average for 5 scores, 10 scores, what have you. So number one, you need to have your average. Step two, we're going to subtract every value of y from y bar to see how much each value deviates from the average. There should be a bar over that y. I'll have to fix that. Step three, then we're going to square each deviation that we made in step two. Step four, we're going to sum up all of those squared deviations from step three. Step five, we're going to calculate n minus 1. I say calculate, but if it's 10, 10 minus 1 is 9. You just do that in your head. If it's 6 cases, 6 minus 1 is 5. You just do that in your head. Then we're going to divide the value we got for step 4 and the value we got from step 5 and get that value. And our last step is we're going to square root the whole thing. If that seems confusing to you, well, I'm going to show you an example. We're going to practice, and we're going to do a lab on it, and you're going to do great. I promise. It does take practice. It does take some thinking about it, and we're going to get there. Okay, so let's look at this one step at a time. So here's our example data. We asked the question, how much time did you study for the statistics exam? We asked a number of students this, and we categorized their numbers, or we collected their data. So this is their time studying. So one person spent 0.6 hours studying, one person spent 1.1 hour, one person spent 1.7 hours, one person spent 2.3 hours, another person spent 2.3, one person spent 2.5, and one person studied for 3.1 hours. So that's our data. So step one, we're going to find the average, right? So we're going to add up all these scores right here, and we're going to get 13.6. We have 7 observations, so 13.6 divided by 7. The average student studied for 1.94 hours. So that's step one, just find your average. Step two, we're going to subtract every value of y from y bar to see how much each value deviates from the average. Remember, we're trying to find out the average deviation from the average. So 0.6 minus 1.94 is a negative 1.34. 1.1 minus 1.94 is a negative 0.84. So we're going to keep on doing that over and over. And some scores are going to be negative, some scores are going to be positive, but we're subtracting every score from the average. Notice we have 1.94 every single time because we're subtracting every score from the average. Now we know if we add up all those deviations, we're going to get 0, right? So let's go to step 3. The mathematicians have solved the problem. You don't add up all of the answers in step 2 because you're going to get 0 every time. What do you do to fix it? We square the deviations. So negative 1.34 squared is 1.79, positive. Negative 1.84 squared is a positive 0.7. Negative 0.24 is a positive 0.05. So do you see how we're getting rid of the negatives? We're squaring every single deviation. So now if we sum up all the scores, we're not going to get 0. And that's what we're going to do in step 5. We've got sum the squared deviations from step 3. So that 1.7, 0.7, 0.05, 0.13, let's add them all up. And we're going to get the summation of squared deviations is 4.4772. Now we're going to calculate n minus 1 for step 5. So we had 7 observations. 7 minus 1 is 6. Step 6, we're going to divide step 4 by step 5. So 4.4772 divided by 6. We're going to get a 0.7462. And then we are going to square root that value. So square root of 0.7462 is 0.8638. It's a lot of steps. It's a lot of work. The computer can do it for us in a second. A calculator can do it for us in 5 seconds. But I do want you to understand each step, what we're doing and why we're doing it, because averages and standard deviations are the centerpiece of statistics. Things to remember. Standard deviation is computed as the average distance from the mean. The larger the standard deviation, it means the more spread out the values are. And again, I'm going to spend a whole class teaching you about interpreting the standard deviation. Right now, we're just learning what it is and how you calculate it. But it's always useful to have 2 standard deviations, one for one variable, one for another variable, and compare them. And when you have a larger number, that means there's more variation. When the other one's a smaller number, it means it has less variation. Like the mean, the standard deviation is sensitive to extreme scores because it's the average deviation from the average. So if you have an extreme score, it will pull it up or down. And if S is 0, if standard deviation, if you calculate it and it ends up being 0 or very close to 0, that means there's little to no variability in the scores. And you would even see that in the data. If all of your scores were like 85, 84, 85, 84, 83, 85, 86, 85, that's very little variability. Everything's hovering around 85, 83 to 86, and you're going to get a very low standard deviation. So S might be like 0.002. That's very low. We can even get whole numbers with a standard deviation.